We are discussing rate law and rate equation and rate constant of a chemical reaction. So as we discussed earlier, the rate of a reaction or speed of a chemical reaction is depend upon the concentration of the reactant. So at the beginning stage of the reaction, the rate of a reaction is very fast because the concentration of the reactant is high. As the reaction progressed, the concentration of the reactant decreased slowly, so the rate of a reaction is also decreased. So, the rate law or rate equation is the representation of the rate of a reaction in terms of a mathematical representation. So, the rate of a reaction is directly proportional to the molar concentration of each of the reactant. So, rate law is the mathematical representation of the rate equation or rate of a reaction. Consider the reaction A mole of A and B mole of B react together and we will get CC plus DD. Here the capital A and B are the reactant, small a and small b are the number of the moles of the reactant corresponding reactant which is participated in the chemical reaction. So the rate of a reaction is proportional to the concentration of the A, capital A and capital B. So if you are replacing the proportionality by substituting the proportionality constant in the equation. So the rate of a reaction, how will you write the rate? Rate is equal to R, that's equal to dx by dt. This is the change in concentration of the reactant divided by dt, that means specified time, that's equal to k. K means it is a proportionality constant into the concentration of the reactant A. Here we are taking the A mole of capital A. So the concentration of the A to the power A, that's depend upon the chemical reaction, into concentration of the B to the power Y. So the x and y may be equal to x is equal to a or y is equal to b. That's depend upon the nature of the chemical reaction, that is an experimental quantity. So R is equal to k into concentration of A to the power x and concentration of the B to the power y. This is the rate equation or rate law, and this k value is known as the rate constant. Next important term is the specific reaction rate. Specific reaction rate means if the concentration of the x and y or the power of the concentration of A and concentration of B is equal to 1. If you are using the molar or if you are using the molar concentration of each of the reactant is unity, then the K value is known as specific reaction rate. Okay. So, next we are discussing some of the rate law of some chemical reaction. First one, 2NO plus O2 gives 2NO2. How will you write the rate? Rate of reaction is equal to K into concentration of NO to the power 2 into concentration of O2. So similarly, the second one, 2NO plus 2H2 gives 2N2 plus 2H2O. So the rate is equal to K into concentration of NO to the power 2 into concentration of H2. Here in the chemical reaction we are using 2 mole of hydrogen, but in rate law there is only concentration of H2, not in the power 2. So from this we can understand that rate equation or rate law is an experimental equation. So we cannot find out the equation by simply writing the stoichiometry of the chemical reaction. So that is entirely different from the stoichiometry of the chemical reaction. So the rate equation and rate law can be determined by experimentally. Okay. Sometimes the chemical reaction constituting of 2 or more steps. So here we can see that the ultimate or overall rate of a reaction is 2NO plus 1O2 gives 2NO2. But this reaction constituting of two steps, first one is 2NO gives 1N2O2. That is a very fast step. So second step is 1N2O2 plus 1O2 gives 2NO2. But this step is very slow. So the rate of a reaction only depend upon the slowest reaction. Okay, remember, in any chemical reaction which constituting of the multiple step, the rate of a chemical reaction is only depend upon the slowest step. Okay, so here in the case of in this reaction, the rate of a reaction is proportional to the concentration of N2O2 plus O2. But if you're looking the rate equation or rate law, there is no N2O2. Okay, but there is NO is there. So here the N2O2 is replaced by NO, that we will discuss in other class. Okay, little bit later. So I hope that you understood the rate law and rate equation and specific reaction rate.